Well, hello everyone, and thank you for joining Ingram Micro's webinar series. Myself, Cheryl Thompson, and Mark Miller have been putting these together for our business partners to keep you guys updated on all the different technology that IBM offers. Today, we're going to be discussing computer vision opportunities with AI. We have our IBM technology advocates with us, technical advocates, Rich LaFrance, Jose Rodriguez, and also Earl Springer. And they will go through some of IBM's AI solutions for your clients. Take it away, Rich.
Great. Thank you, Cheryl, and thank you everyone for attending. So there's a lot going on in the AI or artificial intelligence era, and kind of what we're seeing is we're going from, computers mimicking what humans do to, boy, this is real time. It has to happen now. There's so much data coming in, and it's coming in more quickly. There's so many more data sources in, and they're coming in from different sources more quickly. So we've accepted the fact that a CPU-only solution or technology solution isn't enough. You need accelerators, things like GPUs, things like faster stores, things like faster interconnects. And so we're going to cover that in the slide deck. I've taken slides from a number of presentations. I've included several as reference slides. But if by some chance on any particular offerings or questions that you may have, feel free to put in the Q&A or let Mark, Cheryl, and I know, and we can arrange for a call for additional details. So what you're looking at here is what we consider enterprise AI hardware portfolio. And this is kind of where AI is at the moment, but it's progressing very quickly, where you basically take data, you bring it into a training machine. You train it to teach it, what animals are, dogs, cats, birds, what type of birds. And then you go ahead and you perfect it to an inference by adding either additional information or making corrections or updates to your previous predictions. You'll notice that here's the IBM product line for this solution. It's an IC922, an AC922 for training, and an IC922 for inference. Note that these are all scale-up boxes. And the big reason for that today is most of these workloads tend to be Linux. Linux cores typically are 4-core, 32-gig machines or partitions, and for that reason, you really don't need to go into the enterprise. Additionally, because you don't need to go into the enterprise, we're not taking advantage of the 8 threads that we have on the enterprise, because most of the Linux workloads can support 2 or 4 threads, depending on the configuration at the most. And then lastly, the scale-out servers are the only ones that offer GPUs, and depending on what the current workload is, that makes it perfect for these scale-out offerings. So a couple of things that we're looking at, there's 2 things. One is you want to make sure you get the information there as quickly as possible. Then once you have it in there, you want to be able to train it as quickly as possible. And then you want to be able to inference it or make corrections or improvements as quickly as possible. And here's some of the things that Power Systems bring to the table. I'm not going to read the whole slide to you, but for example, the S924 with transaction systems, 47% higher performance, but look at this, it's half the cores. So we're getting significantly better throughputs, and we're getting a much lower infrastructure. TensorFlow, MongoDB, very, very common, similar results. I'm going to talk a little bit about benchmarks a little bit later, but for now, just understand that these are kind of where the benchmarks currently sit. So if we look at the AC922 and why this is so good for machine learning, it's wide open, and it has a PCI 3 bus all the way through. It has some PCI 4 slots for I/O. It's got the GPUs, and we're going to talk a little bit about what makes NVIDIA GPUs on Power different than NVIDIA GPUs on x86. And for the most part, the NVIDIA GPU is the same. It's the communications to and from. So the AC922 is really good at taking information that's fed into it, analyze it, and send it back out for results. And what do we mean by that? We're typically, 5-6 times the throughput of Gen 3. We have up to 2 terabytes of system memory. Now, what makes the AC922 a little bit different is if by some chance your GPUs do not have enough memory, you're not optimized for the current workload, you can actually take real memory and make it look like it's additional GPU memory. The nice thing about that is now you can work with larger images. So you can either have larger images, or you take a smaller image and you can do twice as many. So you get quite a bit of flexibility there. And we're going to talk to the GPU, CPU, and GPU to GPU links here in a moment. So here's what the NVIDIA link does for us. The NVIDIA GPU in the Intel is exactly the same NVLink that's in Power, except what Power brings to the table is we have NVLink not only between the GPU to GPU, which is on the GPU chip itself, but we actually have NVLink between the CPUs and the GPUs, which gives us significantly better throughput, and that's where we're getting the 5.6 times. So even though the GPU is the same, it's the I/O communications and the bus between them that gives IBM the significant advantage. Here you're looking at what the AC922 brings. This is supposed to show the Summit and the Coral supercomputers that are currently in the national labs. They are the top 2 of the top 3 supercomputers in the world. They've been in production a little over a year and a half, maybe a year and 9 months. They're expected to be in production through the year 2025, just to kind of give you an advantage of how much additional technology the AC922 has back then, even compared to today. They are still number 2 or 3, and this is 1 year and 9 months later. And if you look at how fast technology moves, this is a significant benchmark now. This is a significant benchmark back then. So here's kind of what it looks like. We'll build this thing out. It's Coral. You'll see the AC922 is the server. You're going to see a switch with Mellanox. You're going to see a switch with NVIDIA. Now, the nice thing about this is a partnership between IBM and a lot of partners. We talked about AI can no longer be CPU only. You need things like NVLink. You need things like GPUs. You need things like the ESS building block. And the nice thing is your clients don't have to go as large as the Coral project. They can, in fact, start a single building block and build up. So here's the Power System IC922. This one is very storage intensive. So you can get 24 disk drives and still have 11 I/O slots. So this box is very good about taking data in, ingesting it, and passing it along to the AC922 for training. Additionally, once it's been trained, it's very good for taking information in, filtering it, doing whatever kind of sorts or modifications you want to make, send it back for training to improve. So this is a lot of disk capacity, a lot of I/O with 11 slots, and if by some chance the client would like to have GPU capability, you can. The GPUs would come in the form of an adapter, as opposed to the AC922, it's built right into the planar board. So it's not only hardware that we're talking about. We have to understand that the applications, things like TensorFlow, Python, those kinds of things are able to take advantage of things like the NVIDIA GPUs. And they can take advantage of NVLink. And they can take advantage of the new NVMe disk drives. So from an optimized AI software, it contains hardware. It contains the Power VM, which is the hypervisor or the virtualization. In addition to that, the operating system needs to be able to take advantage of it. And then on top of that, you have the workloads. So here's some examples of IBM Power Systems software. This is Power Systems for SaaS Avaya. For those clients that are existing SaaS and they want to go ahead and add analytics, SaaS Avaya is a very good option for them. For those clients that are not currently SaaS but are considering it, not only can we include SaaS, but we can add this analytics portion to it. Another one is the SnapLNL. So if you look at the far right, a lot of these tools or frameworks, Python, Learn, TensorFlow, Spark, what we've done is we've gone ahead and packaged these things in such a way that they're easy to access. They've been optimized for Power 9. And because they're tools that clients are typically used to using, there is no transfer of skills needed or additional skills needed. They come optimized for Power 9, and that's going to give you the advancements and the advantages that Power Systems bring. Another one is H2O driverless. Out in the market, there's an extreme shortage of data scientists. So what these data scientists, and these are internationally known, they're they're award winners, they go ahead and they write these algorithms, which is how we get the AI insights and how we get our results and how we get the best results and how we make them more specific and more accurate. And what this H2O driverless does is you come in, you bring in your data, it analyzes the data, it looks at what type of data you have, what's the best way to optimize it. And the nice thing is, instead of having a data scientist have to do this manually, this H2O driverless will take that data set and give you the best kind of algorithms and give you the best kind of precision, and you do not need a data scientist to request it. Additionally, if you do need assistance, there's support for this as well at the enterprise level. So the nice thing, if you look at the bottom, is a 21-day free trial. It's kind of nice to play with. You basically go out, and the times that I've played with it, I've taken images. Here's a horse, here's a dog, here's a cat, and just kind of put them out there very simple, and it'll go ahead and it'll make that for you. But the nice thing is you can put in as many images as you want. If you wanted to take the entire, how many photographs you have on your phone and dump it into this H2O driver list, it'll analyze all those very quickly and get you some results. Next thing is visual insights. Nice thing about visual insights, it gives you the opportunity to pretty much point and click. So if you got pictures, you can go ahead, capture the picture, label it, and then now you can go ahead and let's say you want to identify cars that are in a particular data set, or you want to analyze particular animals that are in a particular data set, or if you want to do an inspection, it literally is point and click. You take an image, label it, include it in the data set, and now you can go ahead and make your analysis. We're taking it one step further, and this is Visual Inspector. Now, the nice thing about Visual Inspector is this can be done from a phone, it can be from a tablet. Today, they're Apple devices. My understanding is they're looking at expanding that, but for now, it's the cooperation between IBM and Apple, and you can actually do visual inspections from your phone, take input from the phone. You can actually go ahead and run analysis from the phone. So the nice thing is your phone can actually do data capture, which is ingest. It can do inference, which is like, yeah, we have this data, but look at this. I have more data to input. I can go ahead and do that, and we can go ahead and make updates to our analysis. So it's gone all the way from the AC922, IC922, way out to the edge, which could be at a plant location. It could be pretty much anywhere. So what I'd like to do at this time is introduce something called the Bayesian Optimization Accelerator. And basically what this is, it's a new market, it's a new opportunity. It is very niche. For clients that are HPC or have HPC, this is a perfect opportunity for them to optimize what we understand to be their simulations. So if you look at the oil refineries, if you look at weather, if you look at automotive crash simulators where they run multiples and thousands and tens of thousands simulations, what this Bayesian optimizer does is it looks at the simulation that you just did, and it knows where boy, this is good, let's focus more on this. This is not so important, let's not focus on this. And it'll come up with a recommendation for your next set of simulations. The nice thing about that is where I used to take 100,000 simulations, now perhaps we can do in 40,000 or 50,000. So if you can reduce the number of simulations, that saves the client time, it saves them money, they get the results quicker, and now they can act. The greatest thing about it is this BOA cluster, it's an appliance. It can be integrated with any traditional HPC cluster. That HPC cluster can be x86, it can be Power, it can be ARM. So this kind of sits right alongside. It is an appliance. It includes AC922s, it includes GPUs, and but again, this is not considered, it's niche. It's primarily for the commercial use because customers that buy it are going to want to have some type of return on their investment. We don't have it targeted for universities because that's primarily scientific trials, those kinds of things, benchmarks. So this is primarily for the commercial market where a customer can see value from having a reduction in the number of simulations. This is actually going to be announced next week on the 17th. It'll be available November 27th. I've had the opportunity to get on a couple of these calls, and when they start talking HPC and they talk Bayesian and they talk Gaussian, I was out of my league. So what I recommend is if you have an HPC client, or if you're an HPC business partner and you would like to get additional information on this and perhaps set up a proof of concept so you can get real hands-on, real experience, again, contact either Mark, Cheryl, or myself, and we can make arrangements for that. In my experience, it was over my head. What I recommend is let's get your team aligned with the IBM HPC team and the client HPC team, and I'm sure to be a very effective conversation. I want to go ahead and make sure that we include IBM Lab Services because when it comes to AI design, there's so many things that go into it. What can be optimized? What can we get AI? What is important analysis? What is not important analysis? What is happening right now? What do we want to historically save? What do we have historically saved that we want to use for today? I recommend the AI Design Workshop. It's through IBM Lab Services, and there's a link in the lower right-hand corner for you to engage them. So here's the IBM Power 10. You may have heard that there is no intent to put GPUs into the Power 10. It's not in the roadmap. It will not be in the roadmap. And the reason for that is we'd kind of started this conversation with data is coming at us more quickly than it's ever been. Data sources are coming at us more quickly than we ever can. And what we're hearing in the industry is that, the way we're doing it with inferencing and training and ingest, it's like they can't get the data fast enough. They need the data faster. So what they're actually going to do is infuse AI into the Power 10 chip. There's a lot to make this happen. I often get questions about, boy, IBM announced Power 10 and we're not delivering servers until a year from now. Well, a big part of that is if we take the Power 10 chip and through optimized algorithms and instruction paths, it takes a lot to make that happen. The Power 10 chip is ready. Now we want to go ahead and make sure the operating systems are ready. Not only the IBM operating systems, but Red Hat, SUSE, open source software is ready. We want to make sure our ISVs are ready, so SAP, Oracle, they're ready to take advantage of this as well. So the idea is if you got information going into a database, today we'd go ahead, we'd gather that information, we do analysis on it, and we come up with results. What they're hearing is as the information goes into the database or into the workload, we want to analyze it as it comes in, giving us much quicker results to the data, much quicker results to analysis, and much quicker results for us to make decisions. So Power 10 will not have GPUs. It will, in fact, be infused AI, and you'll see it not only for the Power 10 systems, but you'll see it with the ISVs as well. So that's what we consider to be innovation, and this is what's made IBM Power Systems successful over the years. Real quick, this is a very busy chart, but if you have an idea of what kind of AI software you're looking for, here's the different levels of AI from the hardware to the operating systems to the frameworks. This is a good reference chart. And that's what I had. Thank you. At this time, I'm going to go ahead and pass it over to Jose.
All right. Let me get the, you need to start, let me start sharing my screen here. And let's go with the full screen. Okay. All right. So thanks, Rich, and thanks, Cheryl and Mark, for putting this together. I'm here with my partner in crime, Earl Springer. We are both partner technical advocates. We both work on IBM storage. I specifically work on storage software, but the lines are blurred, let's put it that way. And as Rich mentioned, computer vision really is just one of the applications of AI, of using AI. It has the same workflow. We still have to ingest data. We still have to organize that data. And then you have to go through the AI workflow of preparing that data, doing the training modeling, and then once you get that model, go out there and do the inference. So much of the solution set that Rich spoke about is for AI as a complete workflow, not just computer vision and visual insights and stuff like that. So the infrastructure itself is exactly the same. And storage within that infrastructure would be the same. So I'm going to talk a little bit about what storage and how you might want to use storage, specifically in the on-prem situation. But I will mention the cloud capabilities where there are. Okay, the main storage solutions that we have for an AI environment. Now, if you absolutely, let's say you have one single server that's doing all the work, and you need the absolute most performance out of that server, storage-rich servers might be the proper answer. Another step would be if a flash system itself, by itself. But if you've got more than a single server, if you've got a collaboration, if you've got a grid, if you've got many more servers, and you would need much more I/O coming in and out, then you might want to consider some of the other solutions that we have. And in fact, it's probably the best way to go. The three components that I'm going to talk about, actually there will be a fourth, is IBM Spectrum Scale, IBM Cloud Object Storage, and Spectrum Discover. And I'll go through a little example of how you use that specifically in a computer vision or IBM's solution for that. And then if you happen to be running this environment in a container environment and using IBM Cloud Paks, which is probably a great way of start to implement your container environment, we do have storage specifically for that environment. Okay, so I'll move forward to that. Why would you consider Spectrum Scale? Okay, it's a software-defined solution. Now, we do have 3 different ways that we can deliver the solution. You can just get the software and run it on hardware, whatever hardware you want, as long as it meets the requirements, and as long as it meets your performance requirements also as a customer. We do have an appliance. We call it an ESS, Elastic Storage Subsystem or System. It is think of it almost as a black box, a self-contained Spectrum scale environment that you can bring in blocks. We have different models depending on whether you want capacity or a higher performance, or if you want a mix of the two. And there are capabilities of running scale out in the cloud. That's IBM Cloud or AWS, Google, and I believe Microsoft Azure. If it's not out this month, it should be out by the end of the year. Okay. Now, Scale has the capability of creating an information lifecycle management environment for you. What I mean by that is, as data becomes, let's say, performance requirements start to diminish, or it's not being used at all, you may want to move that data to a lower tier of storage or more cost-effective tier of storage. And Scale has that capability of automatically doing that for a customer by just setting policies. X number of days that the file has not been used, or a file from a particular application. Move it from a higher tier to a lower tier. And it has the capability of using flash, of using disk, using cloud storage if you want to put the storage, the data out in the cloud, or out into tape if you want complete air gap for security reasons, cyber resiliency. Okay? It has the capability of creating disaster recovery environments for you. It also has the capability of creating multiple sites where, let's say, you want local access times for different offices of a client. You can have copies of that data in those offices or those data centers and have a central repository in your main data center where everything is being kept and everything is being protected. And you can use those remote sites as components to a disaster recovery situation. Okay. It has the capability of doing encryption of data at rest, encryption of the data in movement between those remote sites. By the way, the feature that does the remote sites is called AFM, Active File Management. Okay. Data can be compressed so that you can save space. And we do have a version called Erasure Encoded Edition. Basically what this is if you want a smaller infrastructure for your Spectrum Scale, so you're using less servers. You know, there are trade-offs to that. If you want the highest performance, it's not the best for that. Let's put it that way. Or if you want the highest amount of recoverability and resiliency, ECE, that edition, has some limitations. It also has some limitations on its size. But there is a capability of bringing this in and maybe having it in a development site for whatever, where you're just putting things together, or for smaller instances. Okay. Now, the other solution set that we have for a computer vision or AI environment is cloud object storage. Okay. In fact, a lot of the competitors, that's exactly the type of storage that they're using when they're creating. Let's say you're running AI out in the cloud. Okay. The benefit that IBM has here with using cloud object storage is that it is massively scalable, and you can have components of it on-prem. You can have it all on-prem if you want. You can have it on multiple data centers if you want. It can be set up for some performance requirements where, quite honestly, it might be pretty expensive to create an all-flash type of COS environment. But if that's what you want, that can be done. I wouldn't recommend it. But it's all a matter of what the customer perceives is where they want to spend their money. But what COS can give you is the official marketing number is 32 nines of data durability, reliability. So it will be years before you lose. You might have the capability of losing data if you set it up properly. Okay, you can set up, and probably the optimal way of setting up cloud object storage is to have 3 different sites, 3 different instances, and where pieces of the data are being written along with some parity type of information into these 3 sites, and you can lose a site and still be able to recover your data, still be able to serve up an I/O request for it, and rebuild that 3rd site from those other 2 sites that remain, if you set it up correctly. The beauty also of cloud object storage is that its protocol is an S3 protocol. So if you already have applications that are using S3 gets and puts, you don't have to recode to do that. You just have to send it to a COS bucket as opposed to an AWS bucket or a Microsoft. No, I'm sorry, Microsoft Azure. If you're using a blob, you've got to do other things to be able to use this S3 protocol. Okay? But those capabilities are there. Okay. So now that you have this massive amount of data that you're using, either for an AI run or for a computer vision type of solution, I'm going to use an example of an account that I worked with. They have 40 years worth of video out there. Some of it is on analog that's really on tape that has to be converted to digital. And the president now says, I want to be able to determine from my 40 years of TV shows who are the guests, who are the hosts, when was it, when was this tape created, what's the name of the show, those kinds of things, right? For the last 10 years, this account has had a person sit in front of a monitor running some of those tapes and looking at what's on that content, writing down the name of the show, who are the host of the show, who are the guests, and then just in a spreadsheet taking that inventory. Okay, so a perfect solution for this is to have this done automatically. Convert all that analog data. By the way, they're on machines that are no longer supported, that are starting to break down. So they better do something about it before the video goes away. And after 10 years, they estimated they got about 8% of that workload done. So you can imagine how long it'll take for them to catch up. And by the way, they're still creating new material too. Now the new material's in digital, so that's good. But that old material is going to eventually deteriorate. So back then, when we were looking at this solution, it was called Power AI Vision. But what they did is, after they convert the analog to video to digital, then they run it through a computer vision inspection process, where you basically you train it to look for particular people, hosts, look for particular titles, where the title of a show might show up, where the titles and the names of who the hosts were, and maybe the names of guests were, or runners underneath the TV show, and pick up text and pick that up. Okay. But all that information right now they were keeping on a spreadsheet. And what we now have is Spectrum Discover that can actually now take that digital content, put it in a repository, and now associate the metadata, that information about who the guest show is and the host and everything, and associate that to that file. And that's exactly what Discover does. It helps you not only discover what's coming in, it can classify them once you have that metadata, it can create labels, and then when you need to find a particular set of shows. By the way, the reason this president said he wanted to know this is if someone should pass away, they want to go back to some of the shows where that person was in any one of the either movies or shows that they had, right? And that incident had happened, and that's why it surfaced. At the moment, Visual Inspector, what it can do is when it finds an event is basically what the things you trained it to go find. It creates what's called a JSON file, which says, here's the event that I found, here's the name of the event, actor's name, host name, and here's where I found it. Here's the offset from the beginning of the show of where it is. Okay, and that information then can be ingested into Spectrum Discover, associating that file, that movie, that object with that metadata. So now you can easily now go out there and find out where was this person, where has it shown up, and give me all the files that have that. Okay, so that's how Spectrum Discover can actually help you in this environment. Okay. I mentioned that if the AI environment is in a container environment, and especially if they're already in IBM Cloud Paks using that, we have the capability of providing either Spectrum Scale, Cloud Object Storage, Discover. Actually, if you wanted to use the flash systems directly through Spectrum Virtualize, or if you wanted to use Ceph storage or OpenShift container storage, there's a bundle called Storage Suite for IBM Cloud Paks that gives you the capability of using that type of storage in a container environment. And it's called, IBM Storage Suite for IBM Cloud Paks. Here's a little picture of, kind of depicting in how you can get to the data using your containers. You can use the CSI driver if you want to directly, but if you are in a Cloud Pak environment, it's much easier to just use the storage suite because it's already integrated to be able to give you that capability to get in there. Here's some resources to go out there and look for storage specifically for data and AI, and for AI and power systems. Okay. Now, I want to go back to a slide here that I had before, just to give you hints. IBM has been in the computer vision solutions for a long time, and we have had, unfortunately, several names to that package or those products. Okay. Rich spoke about Visual Inspector, Visual Insights. Insights is the group name that does the actual training and creates inference models. Okay. The Visual Inspector, really what it is, it uses those models and it uses that iOS devices to then give you inference on a particular picture or something that you're pointing that device to. Okay. You've heard of Watson. There's a family of products called Watson Discovery AI, and a lot of that has to do with image processing, and video processing. As of March of this year, and you'll still see a lot of hits when you do a Google or Bing search, you'll see Power AI Vision. Okay, that was the previous name of Visual Insights. Okay, so that is that group, but it is the same. It is the exact same product. Okay, and you will now start hearing about IBM Maximal Visual Inspection, and that is it's almost it's a bundle of visual insights with some of the Watson Discovery pieces in there, but it can give you the same results. The reason I mention this is if the way this opportunity that I talked about with Spectrum Discover came up is that the customer was asking about how to, they saw a demo out at NAB in Vegas last year, and they wanted to find out how to get to it. So I had to dig in just to find out what component was out there and all the pieces. I just want you folks to be aware of, if you hear any of these names, they're talking about computer vision, they're talking about AI, they're talking about Watson, and so that you at least know. Start asking IBM about these things, and what kind of capabilities we're talking about. We're talking about inspecting pictures, and video, or even live capture of incidents of things happening out there, cameras. So if you hear Power AI Vision, if you hear Visual Insights, if you hear Watson Discovery, if you hear Maximal Visual Inspection, or if you even hear them say computer vision or computer picture analytics or anything, think of these solutions that we have just presented to you. Okay. With that, I'm going to return it to Cheryl and Mark, and I want to thank you for your time.
Thank you, Jose. Thank you, Rich. This is some great information, especially the Power 10 having AI infused on the chip. I'm excited about that. And I know everybody's waiting to know when that Power chip is going to be released within the Power systems when Power 10 is coming out. Rich, do you have any ETA on that?
I do not have a specific one. I would expect it about fourth quarter of next year.
Okay. It'll be a while. Thank you. I appreciate it. And thank you, Jose, for giving us the updates on IBM Spectrum Storage and how it actually, the different AI solutions that they have with our storage solutions. With that, I want to thank everyone for joining, and all of those who are listening to this from our on-demand links, please reach out to myself, Cheryl Thompson, and I'm at Cheryl with a C, .thompson@ingrammicro.com, or my counterpart, Mark Miller, who's at mark.miller@ingrammicro.com. We look forward to hearing you to get a little bit deeper dive into these solutions with you and your teams and your clients. Thank you and have a great day.